Okay, guys, in each of these, you don't have to read all the picture, obviously, but you have to prove that the side will be similar. So in 11.1 there, it was talking about the small triangle at the top and then the whole triangle. You had to prove that those ones are similar. And they did give you the order in each of these questions. All right, so they told you P, Q, T, and PRA, that's the correct order. Okay, so what you had to do here was, if you're looking at the small triangle at the top and then the whole triangle there, angle P is common. All right, that is an angle in both of the triangles. So that's why you're writing P is common. Remember, the order here doesn't have to be the same as mine. Okay, you can write those three things in any order, but that's usually the first one that I write. If I see that P is an angle in both of my triangles, right? It's an angle of the small one and then of the whole triangle, so P is common. For the second one, you have parallel lines here, so you need to look for that F shape. So PQT is equal to angle R. The reason there is corresponding angles, QT parallel to RS. For that F shape there, and then you have a different F shape over there. So that angle PTQ is equal to S. Now guys, you can't just say T because there are actually three angles at T. All right, so if you just write T is equal to S, you're not going to get that mark. So if it's like this, sometimes they number them. So you can write T1, T2. In this case, they didn't number it. So you have to name it properly. You have to say PTQ or QTP is also fine, as long as the T is in between the other two letters. Yes. 5. So it's 1 for each thing. So 1, 2, 3. Sometimes they give an extra mark for the reason here. It depends on who's setting it really. And then a mark for that statement and a mark for the reason. Okay, now guys, in this case, I didn't work with the sides because they didn't give me all the sides, right? You can only actually do that side and top thing if you have all 6 sides. And we see that they gave us some of the values here, but that's a Y. They didn't even tell us anything about these sides, so we couldn't use sides and top for that one. Okay. Questions on 11. All right, then number 18 was a bit more difficult, okay, because of the way that the picture was drawn. But we do have this triangle at the top and then this triangle here at the bottom. So what you needed to notice is that you could work with 2 Z shapes here. All right, so we have, let me just see which one I used first. So you have that Z shape over there, right? And because these 2 lines are parallel, we know that these 2 angles will be equal because they are alternate angles and those lines are parallel. Okay, so angle B will be equal to angle D. Alt angles, AB is parallel to DE. Then the other Z shape, which is a bit more difficult to see, is this one over here. Right, guys, whenever you see that there are parallel lines, you need to look at those parallel lines and see, do I have a Z shape here? Do I maybe have an H shape? All right, they won't give you parallel lines if you're not supposed to use them. So this Z shape, which is more difficult to see over there, right? So that means that this angle, now can I just say angle C? No, there are lots of angles around that one. Okay, so I have to say ACB. That angle will be equal to, if we look at that Z shape, this angle is equal to that one. Again, I can't just say angle F because there are lots of angles there around F. So I have to say DFE or EFD. Again, it doesn't matter what the order is, as long as the F, the one where the actual angle is, has to be in the middle. Now guys, in this case, we couldn't actually prove that the third pair of angles are equal, all right? But do we have to? If we know that 2 angles are equal to 2 angles, then the third angles will automatically be equal. Okay, and you actually have to use that in this case. So angle A will have to be equal to angle E. And the reason for that is then angle sum in triangle. Okay, if you can find no other way of proving that the third angle is equal to the third angle, your reason can always be angle sum in triangle. Right, you don't actually need to even look for a way to prove the third angle equal to the third one. They will always be equal, and your reason can always be angle sum in triangle. All right, then number 19 was very similar to the first one. The picture was just drawn in a different orientation. All right, but again, guys, we see that we have parallel lines. So as soon as you see parallel lines, you need to ask yourself, is there a Z shape there? Do we see a Z shape with those parallel lines? A Z? No, hey? What about an F? Yes, there's an F shape, all right? And there we have an F shape as well. We have two F shapes. So that means that we're going to have two pairs of corresponding angles that are equal. Angle E is going to be equal to angle BDC. Because of corresponding angles, AE parallel to BD. Then, so that's the F shape that's like lying on its back there. Then this funny kind of skew pointy F shape here at the top is telling us that angle A will be equal to angle, not just B, because now there are multiple angles there, DBC or CBD. All right, so those are my second and third angles that I have there. And then again, guys, if we're looking at the small triangle on the side and then the big triangle as a whole, do we notice that C is in both of those triangles? All right, so angle C is common. And that's actually what I wrote first. But like I said, it doesn't matter what order you put your three angles in. Guys, you have to put equiangular there. If you don't put it there, you're going to lose out on a mark. Okay, they give it an extra mark for writing, or a specific mark rather, for writing equiangular. So please make sure that you are writing it there. Okay, any questions on these three, guys? All right, then we did this yesterday. All right, using similarity to calculate missing lengths. So we did a long example. If you didn't watch the video, I don't know why not. You were supposed to. You're going to have to go watch it on your own time. I'm not going to reteach stuff. Okay, so this was the homework that you had to do based on that. So I'll go through that step by step. Those were the two triangles that were given. And they're asking you to find the value of x, which is the side. Okay, that triangle, yes, and y we had to find as well. Now this triangle is a right angle triangle. So if we had two of the sides, we could find the third side using Pythagoras. But do we notice that we only have one side? So I can't possibly use Pythag to find two sides. All right, I can only use that to find one side if I have the other two. No problem.
Just confirming, break time test is Wednesday the 8th.
Yes, next
They
Wednesday.
got email something from me saying the 7th, like on a bunch of, but that's wrong, right?
Yeah,
We've said
it's
8th,
supposed to be Wednesday.
and we're after school and in 12. Okay,
Because that's when they have maths at the end of the day.
Yeah.
Yeah. No problem. Okay, where was I? All right, we can't use Pythag to find x and y, right? If we had this thing as well, both of them, then we could use Pythag, but now we can't, all right? So in that case, you have to prove that the triangles are similar, and then you need to use your sides and props from there to get the lengths of the sides. Okay, so proving that they're similar, you should all be able to do unless you haven't been practicing, in which case that's your problem. All right, so in triangle EFG and triangle RST, those are the two triangles. Now guys, we do have that both of them have a 90-degree angle in. Okay, so that's easy. Angle F is equal to G, that's given. Now, if we look at the other angles, we actually don't have other angles that are equal, right? We have a 73-degree there, we don't have 73 degrees over here. We have a 17, we don't have a 17 there. But guys, we have two angles here, so we can easily find the third one. All right, angle E, if you want to calculate that one, is going to be 180 minus 90 minus 73. And if you type that into the calculator, you will get 17 degrees for that angle. All right, so if you don't have enough angles, then you're going to have to make a plan to find some angles. Okay, they actually gave us values in this case, so we could calculate that that angle is also 17. Do we now see that we have a 17 over 17? All right, so that helps. So now we can say angle E is equal to angle R. Our reason is not given because it wasn't given that that is 17. We had to actually work that out. And what we use to work that out, 180 minus the other two angles, is angle sum in triangle. So that is our reason there. Okay, because we did 180 minus 90 minus 73. Now we have two pairs of angles that are equal, so the third pairs will automatically have to be equal. All right, if you wanted to, you could have calculated angle T as well, but you didn't have to. But maybe if you just wanted to make sure, if you do that calculation, you will get 73 degrees, which is the same as angle G. So then you can say that angle G is equal to angle T, again, because of angle sum in triangle. Then you have to set up your similarity statement. Now you have to be very careful in the order that you do your letters in. If your order is wrong, everything else after that is going to be wrong. So I usually just do the first one in alphabetical order, but it actually doesn't matter. You can decide. Yeah. You might, yes, unless it gives you values that are completely like unrealistic. Okay, so E, F, G, that is alphabetical order. So I just usually do alphabetical order for my first one. But now, guys, if we wrote E first, E is the 17-degree angle. What angle is 17 degrees in the next triangle? R. So that one must be first. Then we said F. F is the 90-degree angle. S is the 90-degree angle in the other triangle. So we have to put in S in the second spot. Then we had G, which is 73. The 73-degree angle in this triangle is angle T. So that one comes last. Okay, that is how you check your order. The angles that are equal have to be in the same spots. All right, so E first and R is equal to E. So E and R must go first. Those two are almost like pairs. All right, then F and S, F and S, G and T, G and T. Your reason is equiangular. Okay, first part of the work is done. Now we need to do our frog faces, which is what I explained yesterday in that video. You do the frog faces, so you say EF, that's the first I, over RS, that is the first I in the other triangle. All right, so those two sides are pairs, EF and RS. All right, in this case, you could see it. EF and RS will have to be in the same proportion as FG and ST and EG and RT, but you won't always be able to see that. Okay, the triangles are sometimes drawn in a funny orientation. So then you have to look at your frog faces. So again, you do your first I over your first I, EF over RS. Second I, FG over second I, ST. There we have FG over ST. Then you do the mouth of the frog, EG over RT. And because these triangles are similar, we know that the fractions have to be the same value. All right, that would have been our other way of proving it if we had information about the sides. Your reason is similar triangles. Then what you're going to do is you're actually going to fill in the lengths of these sides. All right, EF was actually X, so you put an X there. RS was actually 8. So EF over RS becomes X over 8. Then you have FG over ST, that becomes 24 over 6. So you put the actual lengths of those sides into your fractions. Then you have EG, which is Y, over RT, which is 10. Now I've circled this fraction. That fraction, the middle one in this case, is the key to actually solving for X and Y. You always have to have one fraction that has two numbers, a number in the numerator and in the denominator. Now guys, what is 24 divided by 6? 4, hey? This is equal to 4. Right? Yesterday in that example, we didn't simplify it because it would have given us another fraction anyway, but here it's actually quite easy. 24 divided by 6 is just 4. So what you do when you have your three fractions, we don't usually work with three parts of an equation, right? We normally work with something equal to something. So we're going to split this up into two separate equations, right? So you take the fraction that has an x in, and you make it equal to the fraction that's just a number. Then you take the fraction with a y in, which is the last one in this case, and you make it again equal to the fraction that is a number. That middle fraction, the fraction that is just numbers, that will go into both of your equations. Okay, so you're going to have your x fraction and the number, and then you're going to have your y fraction and the number, always. All right, that's why I circled that one. That one goes into both. And now, guys, when you have this, it's actually an equation that's very easy to solve, because what are you doing with the 8 on this side? You're saying x divided by 8. What's the opposite of dividing by 8? Multiplying by 8. Right? So you have x is equal to 4 times 8, which will give you 32 millimeters. And on this side, with y over 10, that's y divided by 10. The opposite of dividing by 10 is multiplying by 10. And 4 times 10 is 14. Now, if you left this fraction as 24 over 6, it would have been fine. If you didn't write it as 4, you still would have gotten the correct answer. So if you said x over 8 is equal to 24 over 6, like that. Remember, you can use your calculators now in case an exam, so it's fine. You're still going to say that the opposite of dividing by 8 is multiplying by 8. So you have 24 over 6 times 8. Just type that into the calculator, it will give you the same answer. Okay, so it's fine if you didn't simplify that. You will still get 32 millimeters. Same thing over here. If you said y over 10 is 24 over 6. So if you didn't simplify it to 4, you would still say the opposite of dividing by 10 is multiplying by 10. So 24 over 6 times 10. And if you type that into the calculator, you will again get the correct answer. Yeah. You have to put that in, they get marks for that. 1, 2, 3 for subbing in, and then you get marks there. So if you leave all of this out, you're going to miss or lose out on 3 marks. Okay, I want to do another example with you on this quickly because it is difficult. So we're just going to do number 2 from the exercise. So you can just carry on underneath this. So it's exercise 2. This was number 1. We're going to do number 2 together quickly. And I'm going to draw the triangles. I want you to draw them as well, please. Okay, draw that picture, please. Okay, again, we have to find X and Y, which are two sides again. Now, guys, do I have right angle triangles here? No. Okay, they might be right angle triangles, but we haven't been told. So we can't just assume. We can't say, oh, hopefully they are, and I'm just going to use pi just in case. All right. If they are not right angle triangles and you have to find the lengths of sides, you have to use similarity. We first have to prove that they're similar. Then we're going to use our frog faces to set up fractions. And then we're going to solve for X and Y. Okay, that's what you're always going to have to do. So let's write these names of the triangles. We have the one at the top and the one at the bottom. Remember that in your heading, the order doesn't matter. It's only in that fifth line where you say triangle this is similar to triangle this that you have to get your order sorted out. Okay, so in triangle ABE and triangle, I usually just write them both in alphabetical order, but it really doesn't matter. You can write them in any order in that first line. And now we need to prove that these triangles are similar. Okay, obviously we can't use sides and prop because we don't have all of the sides. So we have to use the angles. Now, guys, they've given us parallel lines here. Do we see Z shapes? Yes. All right, we have two Z shapes, in fact. So if we're looking at that Z shape over there, B is going to be equal to D. So angle B is equal to angle D. Now we can just say B and D because those are actually the only angles at those points. Right, the reason is when we're using the Z shape, it's alt angles. And remember, you have to say which sides are parallel. So AB is parallel to BC or CD. Okay, one down. If we look at the other Z shape, right, that one there, we're going to see that angle A is equal to angle C. So A is equal to C. Same reason, alt angles, AB parallel to DC. Guys, even though it's the same reason, you do have to write it down twice. You have to have a reason for each line. Okay, now the third one. So we have two options here. We've already proven that two angles are equal to two angles, so we can just say that the third ones are equal and we can say angle, sum, and triangle. But is there another way of proving that these two angles are equal, maybe? Instead of using angle, sum, and triangle, what else can we say? Vertically opposite angles, all right? Do we see that X shape? So this angle at E is going to be equal to that angle at E. Guys, can I now say E equals E? No, all right, now I have to be specific. AEB for the top one is equal to DEC for the bottom one. AEB is equal to DEC. And now we can say vert op angles equal. Or you could say angle, sum, and triangle. Okay, if you didn't notice the vertically opposite angles there, angle, sum, and triangle also would have been fine. Okay, now we have our three angles that are equal. So now we can say therefore triangle ABE. Guys, you choose the first order. Okay, the order of the first triangle is up to you. The order of the second triangle then has to match the first order. Okay, so I usually do the first one in alphabetical order, and then I match them up after that. So now we wrote A first. And guys, it's also nice if you actually put these symbols in your triangles, then it's easy to match them up afterwards. All right, so angle A was equal to angle C. We can see that they're both stars. So because I wrote A first, I have to write C first as well. We did actually write it there as well, hey? A equals C. So you can also look in your actual steps that you wrote down. A and C, they must go in the same spots. B was equal to angle D. So if I wrote B second, I have to write D second. And then this angle at E was equal to that angle at E. So E has to go last. Reason, important, equiangular. Okay, now we've proved that they're similar. Now we have to do our frog faces. So we're going to say AB over CD. AB over CD is equal to second eyes, BE over DE. Equals mouth, AE over second mouth, CE. The reason, again, important, similar triangles. Are we fine with that step, guys? So the first I connects the first two letters, A, B. The first I here also connects the first two letters, C, D. So those ones go together in one fraction. The second I connects the second and the third letters, B and E. The second and the third letters here are D and E. So those ones go together. The mouths then connect the first and last letters, A and E. And in this case, the first and last letters are C and E. So those ones go together. Okay, now we're going to fill in the actual lengths, the values of these sides. So what is AB? X over CD, which is 20. First fraction done. That is equal to BE, which is 2 over DE, which is Y. That is equal to AE, which is 3, right? Over CE, which is 15. Please circle that last fraction, because it's the only one that has a number over a number. That fraction is going to have to go into both of my equations. Okay, I'm now going to split these three fractions up into two separate equations. So therefore, you don't really have to write therefore, it's fine. We're going to take our x fraction, x over 20, and we're going to make that equal to the fraction that is numbers only. So 3 over 15. And we're then going to take our y fraction exactly as it is. 2 over y is equal to, again, 3 over 15. Now we have to solve for x and y. All right, the first one is easy, guys. When your x is in your numerator, all you have to do is, what are you doing with this 20 here? X is being divided by 20. So when I move it to the other side, I have to multiply by 20. Okay, so you can just say x is equal to 3 over 15 times by 20. Naomi, did you work that out? What is it? 4. Thank you. All right, so the answer there is 4 centimeters. Okay, you just type that into the calculator as it is, and it will give you the answer. So when your variable is at the top, it's nice and easy. Okay. Now, when your variable is in the denominator, it's a bit more difficult, but I do want to teach you guys a trick that I didn't do in yesterday's lesson. In yesterday's lesson, what we did was we multiplied each term by the LCD, and then we solved for y, okay? But what you can actually do, and this is a trick, if your variable, the y in this case, is in the denominator, so at the bottom of the fraction, what we can do is we can take both fractions and we can flip them around. Okay, so we can do this. Instead of 2 over y, we can change that to y over 2. But then I can't just do that on the one side of the equation. I have to do that on the other side as well. So the 3 over 15, I can change to 15 over 3. And that makes it much easier. Okay, so I'm going to write here on the side, variable in denominator then flip both fractions. You're not changing anything in the fractions. You're not doing anything with the exponents now or nothing. You literally had 2 over y, you flip it around, it becomes y over 2. And you had 3 over 15, you flip that around, it becomes 15 over 3. Now guys, what is 15 divided by 3? 5. All right, so you can write that as 5 if you want, or you can leave it as 15 over 3. It's fine. What am I doing with this 2? I am dividing by 2. So when I move it, I have to times by 2. So y is going to be equal to 15 over 3 or just 5. Right? You can also just write 5 there. Times by that 2. And that will give you 10 centimeters. All right, any questions there, guys? Those are the steps that you always have to follow. Okay, do you understand how important the order of my vertices here are, the order of the letters? Because I use those letters to set up my fractions. And then I use those fractions to calculate x and y. Right, so if your order is wrong, your fractions are going to be wrong, and then your x and y answers are also going to be wrong. We do give CA marks, but obviously, yeah, you do want to get those right. Okay, so you have 24 minutes still left. I want you to do numbers 3 and 4 from exercise 2 on your own. I will put them on the board, all right, because they are on Google Classroom. So numbers 3 and 4. And guys, you're going to do the exact same thing. In number 3 and in number 4, first you're going to prove that the triangles are similar. Then you're going to set up your fractions. You're going to fill in your values. You're going to split it up into 2, and you're going to solve for x and y. All right. So you're practicing these exact steps. You have it now for 2 examples, and you're going to do it for 3 and 4 as well. Yes? Sure? All right, guys, I'm going to put that on the board for you quickly. And then you have the rest of the lesson to work on that.